Hi, here are some more questions on the same topic what we've been discussing in our previous videos, angle of elevation and angle of depression. So if you have not gone through those, please watch the prior videos that are uploaded so that you may have a better idea about angle of elevation and depression. So for this particular question, we start from the top of a cliff 52-meter high. The angle of depression of two ships due east of it are 36 degrees and 24 degrees given respectively. We need to find the distance between two ships. So in this question, if you see, here you go, this is a cliff that is 52, this is 52-meter high, right? And we assume that there are two ships. This is ship A and this is ship B, and we need to find their distance apart. Okay, so this is what we are looking for, this distance between A and B, right? Okay, further information we have, suppose this is my level ground. So let's draw a straight line that is parallel to this, and angle of depressions are given. Okay, suppose this is A, B, that be height of, that is the height of a cliff. Okay, and suppose here is ship 1 and here is ship 2, and we need to find distance between two ships. This is a right angle triangle, right? Okay, angle of depression of first ship is 36, so this would be angle of depression 36 degrees, right? And angle of depression with the second is 24, so this is going to be 24. Now we know that if two lines are parallel and this is a transversal, then these two angles are known as alternate angles, right? They are always equal. So if this is 36, this is also 36 degree, and this is 24, this is also 24 degree. Now, in order to find distance between these two ships, we have to find this length. Let this be T, that is AS1. In this small triangle, we apply right angle triangle concepts or trigonometric ratios. So we could say that, okay, tan of 36 degree would be equal to 52 opposite over adjacent. So T would be equal to 52 upon tan of 36 degrees. Okay, this becomes T is equal to 71.57. So this is length of T, that is 71.57, or we say that ship 1 is 71.57 apart from this, right? Similarly, now if I assume the bigger triangle A, B and S2, suppose let's consider this triangle now, it's A, B and S2. You see this is 52 degrees and that is AS2 distance, and this angle is 24. We again apply tan here, so tan of 24 will be equal to 52 divided by AS2. So AS2 would be equal to 52 upon tan of 24, and this distance AS2 would be 52 divided by tan 24 becomes 116.79 approximately. Now this whole length is 116 and this is 71. So if I want to find distance apart, they are ship 1 and ship 2. That is going to be AS2 minus AS1, right? That is 116.79 minus 71.57. That becomes approximately equal to 45.2 meters. So you say that ships are 45.2 meters apart. Have a look again. It says from the top of a cliff 52-meter high. Suppose this is a cliff that is 52-meter high, right? Angle of depression of two ships due east. Okay, purpose of saying due east, that means they want to tell you that both the ships are on the same side, okay? Are 36 and 24, 36 degrees and 24 degrees. They are angle of depressions. We need to find how far apart the two ships are. That's ship 1 and ship 2. So let's draw a triangle like this. This is height, this is the cliff, this is ship 1 and ship 2. We know that angle of depression is always measured from point of observation with the level. Okay, so suppose this is level ground, this is the level, and that is going to be 36-degree angle of depression, and the angle of depression of the second ship is 24. So here you go. And we know that if we have alternate angles like this, parallel lines are transversal cut, these two angles are same. So if this is 36, we believe that this is also 36, and if this is 24, this is also 24, right? Now this is the question. We need to find distance between two ships. So this is what is required here. So we have tan 36, we apply tan 36, that is opposite over adjacent. So tan 36 is 52 by t, that is 52 by tan 36. That means this length AS1 is your, this is AS1, that is 71.57, right? And then we assume that ABS2 is a bigger triangle. This is 52, this is 24. Okay, we can find distance of A to S2, right? So again we apply tan 24 equals to 52 by AS2, that is 52 by tan 24, that makes it 116. So now we are looking for the distance that both the ships are apart. So we know AS2 is 116.79 and AS1 is 71.57. We subtract them and we get 45.2 meter. That is the distance both the ships are apart. Okay, let's try one more question here. It says from the top of a building 32 meter high, the angle of elevation and depression of the top and foot of an aerial mast are 40.67 and 22.42 respectively. We need to find the height of the mast. Okay, so now let's assume that this is the building that is 32 meter high. You are standing at top of this building and you're observing, and we assume that this is PQ, the tower, right? And as observed from this A, we see that angle of elevation is 40.6. So you're standing at this, this is your level, okay? And we know that whenever we observe angle of elevation, like any angle, any object that is above our level, it makes angle of elevation. So this is 40.67, that is angle of elevation, and 22.42, that is angle of depression when we observe the foot of this tower. As given that this is 32, so obviously this is going to be 32 meter, okay? And we need, this is 32, we just need this x, okay? And then we'll be adding this 32 to x to find the height of this mast. In order to find this x, first I need to find AR, that is equivalent to BP, okay? According to alternate angle theorems, this is 22.4, so is this 22.4. So now we have in triangle ABP, in triangle ABP, this is A, this is B, this is B, right? We apply tan of 22.4 is equal to 32 divided by BP. That means BP will be equal to 32 divided by tan of 22.4. So BP is going to be 32 divided by tan of 22.4. So if you see, that is 77.56. So if this is 77.56, so is this 77.56. Now again, in triangle ARQ, we again apply tan of 40.67, that will be equal to x divided by 77.56. So that RQ would be 77.56 times tan of 40.67, and this is 77.56 tan 40 is 66.64 meter, right? That is the length of x, that is 66.64. now for the length for PQ, that is the height of tower, that is B equal to 32 plus 66.64, right? That is going to be 98.6 meter. So that is the final height of this mast, okay? That is 98.6 meter. So have a look. What we have learned in this question is, it says from the top of a cliff 52 meter high, angle of depression of two ships due east of it are 36 and from the top of a building 32 meter high, the angle of elevation and depression of the top of the foot of a aerial mast are 40 and 22 degrees respectively. Find the height of the mast. This is building, that is 32 meter high, and this is the mast, okay? From top of this building we observe angle of elevation, that is 40.6, and that is angle of depression, that is 22.4, right? First of all, this is 32, obviously this is going to be 32. Now this is the remaining part in height of this mast that we need, okay? For this we need this base that is equivalent to this. So in this ABP triangle we apply trigonometric ratio, that is tan of 22.4 equals to opposite over adjacent, that is BP is equal to 32 by tan 22.4, BP is equal to 77.56. If this is 77.56, now in this ARQ triangle we can apply tan 40 equals to x divided by 77.6. So opposite or adjacent, and x would be equal to, that is RQ 66.64, and at the end we are looking for the height of the mast. This is height of the mast, right? So total height would be 32 plus 66.4, that is 98.6 meter. So height of the mast would be 98.6. So stop this video here, and before we move on, I want you to solve these questions yourself and then see the solutions in it, okay? Thank you very much. Assalamu alaikum. Allah Hafiz.